Hello and welcome to the next in the series of PIC Microcontroller setup and programming series that I'm doing. This is lesson 2. This will be on the LED on project, as I like to call it. Basically, we're going to be very simply doing some very simple code. I want to demonstrate inputs this time using the CCSC compiler and how to input some switches into your system and react to it. We're basically going to be doing turning a couple of LEDs on and off based on what position the switches are in. We're just using some momentary switches, as you can see with switch 1, switch 2. There's just going to be some momentary push button switches. Later on, in later tutorials from this point on, we will probably be doing a little more advanced stuff using some peripherals. Next tutorial, hopefully, I want to introduce the MAX232 chip. Most everyone loves to be able to interface with a PC or basically talk to a computer through your PIC controllers, and using the MAX232 transceiver chip from Maxim Semiconductor, you can do that. You can interface it to an RS-232 port. In later series we'll start dealing with the USB, the Universal Serial Bus, but for right now we'll keep it simple. We'll just deal with the RS-232 port things, and then from there we'll move on to other things. We'll experiment with some of the I2C bus, do maybe some flash memory, adding flash memory, external flash memory. Some chips have their own onboard flash memory that you can store things in for later use, but sometimes that tends to be limited, or you may have to increase the size of the chip or go to a higher type chip like an 18F series, which could be higher than the 8-bit series that we're using, the 16F. So you may add some external flash memory, as well as maybe some other things like a Dallas Semiconductor 1307 chip, which is a real-time clock that utilizes the I2C bus, and just things like that. That's kind of some prelude to the future. But for right now, we'll go ahead and finish up with the simpler stuff, and I'll show you how to use your inputs, and input some data into your system. Right now we'll go over the hardware connections of our system. We've got our 12-volt supply, and we've got our 7805 voltage regulator, and our two capacitors for noise, our 100 microfarad on the input and 0.1 microfarad on the output for noise suppression. And then we've got our 10k ohm resistor pulling that mem clear to a high, still in here. Like I said, I wanted to get you used to seeing that, because when we do things like bootloaders, I'll be showing bootloaders, how to install bootloaders on your system and things like that in later presentations. You'll be using the I think the RTS or the DTR line on the RS-232 port to flip the mem clear, so that way it can cycle the mem clear to reset the chip, so you can load different codes and things onto your chip. So anyway, I just wanted to get you used to seeing that resistor. Now we have our two switches, and how we tie the switches in is with what's called a pull-up resistor network. There's two different types of resistor networks that you can use, pull-up and pull-down. Pull-up resistor networks are basically, you have a resistor tied to a high that then pulls the pin up to a high. And then you basically then can run this through a switch to ground, and then when you close in the switch, it'll actually will pull that pin to a ground when you close it in, and that is called a pull-up resistor network. Pull-down is basically the opposite. Instead of this resistor being connected to a high, it'll be connected to a ground, and then instead of the switches being connected to a ground, they'll be connected to a high, so that way it pulls the pin through the resistor down to ground at all times, and then when you close the switch in, it pulls it up to a high. Either way, either one works. I like the pull down resistors, or the pull up resistor, excuse me. Just my personal preference. It's whichever you want to do. It'll work either way. You just got to make sure that you keep the logic right, and that you're always going to be receiving a 1 until the switch is pressed. Then you'll see a 0. whereas if you use the pull down resistor network, it'll always be seeing a 0 until the switch is depressed, and then it'll see a 1. So you just got to make sure you keep your logic correct, whether you're using negative logic or regular logic. So anyway, we've connected these to, I'm going to connect these to ports RA1 and RA0. So switch 1 is RA0, switch 2 is RA1. Then over here we got a couple of our LEDs, and again we have our 470 ohm shunt resistors in there to allow it so we don't damage the LEDs, driving them straight off the pin. We got our 470 ohms in there, so that way that LED is nice and bright when it lights up. And we've got RC0 and RC1, so pin C0 and C1 have the two LEDs on it. LED 1 is on 0, RC1 is LED 2. And that's pretty much it for the hardware. Very simple, very basic. So we'll go ahead and move on to the programming side of things. Pull up our MPLAB IDE. Now I've gone ahead and set up everything for us. I went through in our previous tutorial on how to actually create a project, add your source files in, your header files, and what the fuses were, and your delays, and all the necessary components and commands to set up everything. So we'll just go ahead and get right into it. First off, we'll go ahead and I think what we're going to do is I'm going to add a couple of define statements just to make your life easier. You can always do this. We'll add define, and we'll say we want switch 1. Whoops. And switch 1, if you remember back to our drawing, switch 1 was connected to our A0, so we're going to have that be pin A0. Then we're going to have another define. We want switch 2, and that is going to be connected to, if you look, switch 2 is connected to our RA1, so we're going to call that pin A1. Now we need our two LEDs. We'll say LED 1, and our LED 1 is connected to our RC0, so that's going to be connected to pin C0. And respectively, LED 2 is connected to pin C1. Just like our drawing showed, LED 2 goes to C1. Okay, so now instead of having to type pin C0 or C1, we can just type LED 1, LED 2, switch 1, switch 2. Use it like a variable. It makes your life a little bit easier, makes the code a little more readable. If anyone else is like helping you code things, it makes it just easier to keep under control of what pin is what. So it gives you some labeling. So now we're going to go ahead and set our tri-state registers. Again, the other lesson we showed how to do this. We're going to go ahead, and since we have 6, I just like going ahead and doing it in binary. You can do it in hexadecimal. It's totally fine. It's no problems, whichever preference you want. I like binary just because I can see it. When I do hex, I kind of have to stop, think about the number for a minute to see which one is where the ones are, basically where the inputs are and where the outputs are. Whereas you type it in binary, you can just glance up there just in case if you make a mistake on accident. It's a little easier to see it because you can see exactly where the inputs and outputs are. So for this one, our switches, we're going to have A0 and A1. So remember, it always goes in binary, it's going to go from right to left, not left to right. So we start at A0 is the first digit, then 1, 2, 3, 4, 5. So we want the first two to be inputs, so we're going to set those to be 1. We also need to set up our port C, and C is all outputs because we got our LEDs, so all of it will be 0. So big deal. So now we're basically going to create an infinite loop, so that way this doesn't run once, and if you don't press it within microseconds and press a button, it'll skip over it and then be done. We're going to create an infinite loop, and I like using the for statement with two semicolons. You can use while true or any other loop that you can just make infinite. Just whichever one is your preference. I like this one. Now we're going to do our checks. We're going to say if, and then we're going to use the input function. And now it's where you got to remember your logic. Right now, without the button pushed, it's going to be held high. So we're going to check to see if it's not input. Oh yeah, I forgot we switch 1. And what this input function does is it basically returns a 1 or a 0 depending on whether it has 5 volts on that pin or 0 volts on that pin. So basically right now the way that it's set up, if we go back, we're pulling switch 1, we're pulling it to 5 volts, right, all the time without the switch being pressed. It's 5 volts. So it's going to, if you type in, if just the input command, just input, is going to return a 1. So we want to say when it's not input, you know, with the exclamation mark, when it's a 0 basically, that's when we want to do something. So now we're going to say output high, and then we're LED 1. That will turn our LED 1 on. Now we want to check. We want to say else. Else we'll keep it off. Whoops. Low. LED 1. Okay. So now we're going to check. We'll check the second switch. If not input, switch 2, then output put high on LED 2. False, otherwise put a low on LED 2. Alright, that's the end of our main function. Oh, and one thing that I forgot to do here is when dealing with the output high and output lows, if you want something to stay off, if you don't designate at the beginning of your code which state the pin is going to be in, the output pin will be in, then basically it floats. So it could be unstable. You could get high when you don't want it or low when you don't want it. So just go ahead and put them both low right now in our case. And then low LED 2. And then that way you ensure that both of them will be turned off before you actually begin running. So that's pretty much it. We'll go ahead and build the project. Move this around up here. Go ahead and build the project. Looks like I have one error. Oh yes, missed that. Right, there's no equal sign there. That's my bad. I'm so used to setting variables and things. Okay, so basically that's pretty much in a nutshell how to make an LED blink on and off. Now, one thing I will show you in this tutorial is how to simulate your code using MPLAB IDE. If you're doing very basic things like this, where you're just doing inputs and outputs and turning things on and off and just very basic highs and lows and things like that, you're not doing any serializing data or doing any hooking up to any peripheral device and going through that and stuff like that, you can actually use a simulation software that's very good that MPLAB comes with on its own.